second part of what we're doing is unit 3.1, or excuse me, 7.1b, okay? And this one's we're going to be finding, or it's going to ask you to state the domain of rational expressions. Now, hopefully you remember what domain is because we just did it. Okay, so what does it mean for something to be a rational expression? A fraction. Okay, and what do you know about domain? Domain is what? Domain is all possible values of x. All possible values of x. Okay, we're not going to do anything with range because there's no y's involved here. It's just going to be x's. So all possible values of x. So since we're dealing with fractions, what do we not want in a fraction? Well, we don't want radicals, okay? But in a fraction, you do not want the denominator to equal what? Right. You do not want the denominator equal to 0 because if you have a denominator equal to 0, so if you have like anything over 0, what does it become? Undefined. Okay, so we want to get answers. So we're basically asking, what can we plug in for x so that you will get an answer? Okay, what can you plug in for x so that you will get an answer? Okay, so these should be a little bit easier. Okay, so for the first part, we're going to ask you to state the domain. So state the domain, state the possible values of x. If I gave you for number 1, f of x equals x plus 7 over x. State the domain. So for domain, you're always going to start with all real numbers.
She told me that I'm your son.
Okay, come on in. Mr. Day's not here today?
He has to move to PE.
Got it. That's okay. Go ahead and come on in. Yeah.
Coach Day.
Oh, wow.
On purpose.
Hey, my pencil.
For 6th period.
Am I done?
No, you're not done. Okay, so all real numbers, you're always starting with all real numbers, except what? I do not want x to equal what? X cannot equal 0. Now, this one, since it's just an x in the bottom, it's just all real numbers except, basically this means except x equals 0. So this is your answer. Okay, thank you. This is your answer. You're done. So basically you can plug in any number except 0 and you would get an answer. That's it. You're done.
You said this was easy. Is this for all of these?
This is not easy?
Well, now we just gotta understand how it works.
Okay, because we don't want zeros in the denominator, right?
Yeah.
So all real numbers just means anything except 0. So it's always going to start with all real numbers, then you write your exceptions. Okay, so let's try another one for number 2. Okay, number 2, if I give you f of x equals, hey, f of x equals 5 over 2x plus 3. F of x equals 5 over 2x plus 3. So you always start with all real numbers, except, is this going to have exceptions here? Yes, because there's an x in the bottom. So we're going to figure out the exceptions. So to find exceptions, set the denominator equal to 0. Okay, so you set the denominator equal to 0 and solve for what x cannot be. Okay, so all you have to do here is we're going to set this denominator equal to 0. So 2x plus 3 equals 0. Then what would you do to solve? Move the 3 to the other side, so 2x equal to 3. And really, we're figuring out what it cannot equal. So let's put that line through it. 2x cannot equal 3, so x cannot equal what? How would you solve? How would you get x by itself? Divide 3 over 2, okay? Don't let this little slash through the equal mess you up. You're still solving exactly the same as if the slash wasn't there. So x cannot equal 3 over 2, so that is your exception. So you can plug in any number except 3 over 2. Negative 3 over 2. Thank you, Tanner. Sorry. I'm sorry. When I subtracted that, I should have made it negative. I apologize. Okay, so when you subtract 3, it should have been, I apologize, 2x equals negative 3 cannot equal negative 3. So x cannot equal negative 3 over 2. That's your answer. Okay, so state the domain, that's your answer. Okay, how about if I gave you something like this? For number 3, if I gave you f of x equals x minus 2 over 4. F of x equals x minus 2 over 4. When we're doing domain with fractions, you always start with the domain as all real numbers. Are there any exceptions for this one? Would it ever be possible to plug in anything for x and get a 0 in the denominator? No, it's not possible. So you can plug in anything for x. That's your answer. So if there's no x's in the bottom, it's just all real numbers. Stop touching.
I'm not even.
Stop touching.
I'm the victim here.
Stop touching. Okay, let's try another one. For example 4. Stop it. F of x equals x squared plus 5x minus 14 over x squared plus 9x. X squared plus 5x minus 14 over x squared plus 9x. What did I tell you about domain? We always start with all real numbers, except, okay, we know there's exceptions here because there are x's in the denominator. So how do you find the exceptions? Set the parts not equal to 0, basically. So x squared plus 9x, what cannot equal 0? So how would you solve this? If that line wasn't there, what would you do to solve? You've done this before. Factor and solve. Factor, set the parts equal to 0. So how can you factor x squared plus 9x? Take out GCF of x. Left behind is what? X plus 9. Set each part equal to 0 or not equal to 0. So x cannot equal 0. What else can x not equal? How would you solve for x here? Subtract the 9, so x also cannot equal negative 9. These are your exceptions. So all real numbers except 0 or negative 9. That's the domain of your function. Okay, is this difficult, easy? All you're doing is factoring and canceling. Factor and cancel. That's it. Factor, cancel, that's it. Okay, questions so far? Because you're not exactly done. Go live. Okay, last part. Okay, last thing we're going to do is, these are going to be kind of like multiple choice, and I want to know, when is this true? When is the following true? Okay, when is the following true? And it's going to be for all values of x. For all values of x. For no values of x. Or for some values of x. So when is the following true? Sorry, I didn't write it in the for. For all values of x, for no values of x, or for some values of x. You might also see this written as always, never, or sometimes. These are, oh, sorry, you couldn't see that. These are the ones that they like to ask you on standardized testing, okay? So if you're a junior, yes, you have to take what's called the SBAC test this year. It's the new STAR, okay, what they've replaced STAR with. If you are not a junior, if you are a sophomore, you will take it next year. If you are a senior, you will take it for your entrance exams, okay, to figure out where you're getting placed when you go to college, what math class you're being placed in. You may also see stuff like this on SATs or specifically on ACTs.
What test did you say it was called? ASVAB?
SBAC.
Oh, okay.
Yeah, no, not ASVAB. That's a military thing. And that's not on here. Okay, so for this one, when is this true? Always, sometimes, or never. So for example number 5, 16x squared over 10 is equal to 8x squared over 5. When is that true? Always, sometimes, or never. So to figure that out is you need to figure out if it is reduced correctly. Okay, so first off, is this reduced correctly? So first you have to check to see if it's reduced correctly. If it is reduced correctly and there are no x's in denominator, then this is always true. So if it's reduced correctly and there are no x's in the denominator, that means it is always true. That's what that means. So first you need to check to see, is it reduced correctly? If it is reduced correctly and there are no x's in the denominator, your answer will be always. Okay, I have 2 more. Number 6. Is it always, sometimes, or never true that x plus 7 over x squared minus 49 equals x minus 7? Is it always, sometimes, or never true that x plus 7 divided by x squared minus 49 equals 1 over x minus, or excuse me, equals x minus 7? So first thing you want to do is figure out, is it reduced correctly? How would you reduce this to begin with? What did we do in 7.1a? Starts with an F. Factor, yes. So the top can't be factored. How can you factor the denominator? That is what kind of factoring? Difference of squares. So x plus 7, x minus 7. What would reduce there? So what should the answer be here? 1 over x minus 7. Can you just automatically move that to the top because there's a 1 there? No, so when would this be true? Never. Okay, they didn't reduce correctly to begin with. So this is a never. Okay? This is not, that's not correct. If you reduced correctly, you should get 1 over x minus 7. They didn't leave the 1 in the top. It'd be like saying, is 2 over 10 equal to 5? No. Okay, if I gave you 2 over 10 equals a whole 5, that's wrong. Okay, 2 over 10 reduces to 1 over 5. They forgot the 1. It's kind of important, okay? It's kind of important, okay? Last one that we're going to do, okay? You guys are going to get this, okay? It's just factoring. X squared plus 6x over x squared minus 36. Is it always, sometimes, or never true that this will equal x over x minus 6? So, first thing you need to see is this reduced correctly? How would you factor the top? Take out an x, left behind would be x plus 6. How would you factor the denominator? Difference of squares, so x plus 6, x minus 6. What reduces? These go away, so did they reduce this correctly? Yes. Okay, so if reduced correctly, if it is reduced correctly, and you have x's in the denominator, okay, which this one does have x's in the denominator, what you need to do is use the larger denominator to find the exceptions. Okay, it's just like domain. So how would you find the exceptions here? Which one is the larger denominator? The x squared minus 36 or the x minus 6? The x squared. So you would set this not equal to 0 to find your exceptions. We already factored this to be x plus 6 and x minus 6. So if you set these, what cannot equal 0? What values of x can you not have? What values of x can you not have in your denominator? How would you solve here? Subtract 6, so x cannot equal negative 6. So we're just solving. Solve for x. Okay, use the inverse operation. X cannot equal negative 6. X cannot equal positive 6. So when is this true? Always, sometimes, or never? Sometimes. Okay, this would be for some values of x, or you could write, or sometimes it'll ask you sometimes. Okay, so depending upon what the wording is, it's either for some values of x or sometimes. Okay, again, homework is up on the board for this.